Test. Chair noises. Excuse me, my desktop cam is not working. There we go. Alright, what am I trying to do? I want to finish this, get a boot on it, and then boot this connector so I can say one of them is done. What that is going to require is a short length of Raychem Atom So I have 8mm, which will shrink down to 2mm. Then I have 24, which will shrink down to 6. So I'm going to chop off a little piece of this. And then we're going to surmount that, and actually this might be just the right size. It's the kind of piece that I'd probably want to throw away normally, but every once in a while something like that comes in handy. Plus it's probably 25 cents for that piece right there. Gonna do a little audio check on YouTube, see how that's coming through. Audio check. Audio check. Oh, it's beautiful. These are good levels. So I just want to shrink this enough to close the gap. So this will shrink down to well within specifications. Alright. So we got that. Now what I need to do is to take up the difference, since this only shrinks down to 6. It starts out at 24, it'll go as small as 6. But if you measure this, we're only getting 4.2, 4.3. So that means this would end up being a sloppy fit. So what I've done with this little 5.18, it's still technically not enough. That's okay. I think we can... I want to try it and see where that gets me. Or should I just bite the bullet and double it up? Correct thing to do is to double it up. It's Ryan ZZZ. Welcome to the channel. How are you doing? Is that It's Ryan asleep? Alright. That was exactly a centimeter. I'm gonna do the same thing again. This piece is so short, I don't think there's any risk that it's gonna shrink in length too much. Trying to do this without burning my hand because this air is a mere 700 degrees Frankenstein. That's pretty good right there. It's not a bespoke suit, but that should give me enough diameter to take up the difference between 6.21. So that means this should shrink down just tight enough to grip onto that. Probably use one that's kind of shitty. Cognitive pause. I'm gonna call that 35 millimeters. I don't know how it's gonna look. I'm gonna give it the old chop, but stuff. It's kind of hard to do this when it's this wide. And still get a square cut, so you have to micromanage it and really get in there. Even then, it's not perfect. You get these little flaky things, little dingleberries. But when it shrinks down, that might go away. This is a Deutsch connector. It's a lipped receptacle. No, it's a lipped plug. That's the receptacle. So I want the nice side up. This one I might just abandon the heat shield there, because it's kind of hard to see what's going on. Holy shit, that's hot. A little bit too far up. It's getting soft. A little too soft. Okay, it's better. Dress it up. I don't really want the lip of this thing sticking out too much. I think it's time for a different attachment on this heat gun. I need to focus the heat a little bit more. If you have any questions about what I'm up to here, feel free to ask. This project has been ongoing for quite some time. So this isn't bad. There's a better way to do this. Using the heat shrink that shrinks down a considerable amount is perfectly fine, but they do make boots that are better for this purpose because they don't shrink very much around the lip, but they shrink a lot on the other end. And this one has a pretty consistent shrink rate. But as I'm finding here, it's kind of hard to get it to shrink down that last little bit. There's still kind of an opening here. Either way, once it hardens, I mean, it's not going anywhere. It's just kind of an aesthetic thing. It looks pretty good though, I'm not too dissatisfied with that. But this here is going to be carrying 120 volts. So this is the bed heater power. This is going to plug into here. And then that's going to take power from this relay here through this connector, which will be bulkhead mounted on the side of the printer's enclosure, and then that'll connect to the bed. I have a 120 volt silicone heater from Kinovo under there, and that's how it's going to get power to the bed. 120 volts versus 12 volts. Should heat up very quickly. cooling off nicely. Starting to get a little bit more rigidity to it. Now's the time to shape it. Once it cools down, it's hard like rubber, like a hockey puck. So that end is done. Jesus. Just trying to stay organized is a constant battle with yourself. Alright, this end. Now we have to deal with this end. And this Kapton tape. It has a weak adhesive, but it is not easy to get off. Once you got a couple layers of it together, it's extremely tough. It doesn't like to just be pulled off the end, so you actually have to get that free end and unravel it. Right. So using the same setting as last night. Get there into the 18 gauge pocket. "18 gauge is a relatively large wire diameter for this project, so the wire tends to want to stay going in one direction. So now what I'm going to do is take the trusty DMC crimper, bust out my female terminals, female pins I should say, add that in, complete the crimp cycle, and there it is. As good as it gets. Crimp. That is a 8 indent crimp. So these little jaws in there collimate in on that and gives you a very precise, very repeatable, and very predictable crimp that is super strong. Twist these back together. Based on what I learned from this last one, I'm gonna need to probably preemptively do this. I also want to look at some of this other heat shrink I have and see if maybe there's a shrink ratio that's more to my advantage. Because this 3/4 inch SCL. This stuff is a lot more rigid, but the shrink ratio is a lot less than this stuff, the ATUM. I'm gonna have to consult the bones. So that definitely fits. But I have to actually take a second and look this up. I'm going to go into the data for TE Raychem SCL. Alright, so 3/4 inch. Thankfully they give us millimeters, so you don't have to do any dumbass American arithmetic to figure out what that size is. Again, this is 4.36. I would need to double that. Or use 3/8, and there's no way I could get 3/8 over top of this connector, so I'm just gonna end up doing it the way I just did. Because again, in this application, you can actually buy a boot that's specifically designed to shrink at exactly the right proportions on this type of connector to a wire this small. Alright. Need another piece of SCL. I think that length worked out pretty good. I could perhaps shorten it a scotch, but I think I'll actually keep it the same. Pretty sure I remember that as 35. Turned out pretty good. Chopper did its thing. Now back to the 8.2. Need two 1 centimeter pieces. Actually could have been a little bit longer, but should be wrapping this with Kapton. Alright, I should be safe to proceed here. I'm gonna pin this. Before I can pin it, I have to test the orientation of the leads to make sure that the ground is on the bottom on pin C. So I'm trying to get to so these are gonna kind of cross over because it's a male plug on both ends. Which is a little bit weird, but it's the thing that made the most sense here. Because you're not very likely to get shocked. I mean, you can't get to the 120 volts in there unless you put this in salt water or something. I have no worries about that. I do need to validate which pin is C. That's B or so. Alright, that should be C. C is going to go in the bottom. Trying to be mindful here of the orientation. Alright, so that means C. According to my documentation here, that would be this pin. This should be A. Should be B. Should be C. Same here. Once again, another mistake in my documentation. For whatever reason, Deutsch has numbered these A, B, and C. I don't quite get why they did it that way. But this should be, as a mating, A goes to A goes to A, and then A goes to A. As long as C is the same all the way through, because C is the ground pin, the other two are hot and neutral, which once you're out of the relay doesn't really mean anything, because it's alternating current. So this thing has to go pretty far in there. And not only that, I kind of need to know which one of these is going to be E. C, and that's B. Should be labeled. I didn't really leave very much room to play here. I don't know if that's going to be an issue, but this little spot of tape probably needs to be a little further down. I don't know. We'll see. See if I can get all these in there at once. It's kind of like not recommended, but do what you gotta do. Yeah, it's not gonna work. Even this cheap Chinese Kapton tape is still not fucking around. It's still pretty legit. Especially if you get it on there tight. Alright, got a little bit more slack, but now I gotta retest all these, figure out which one is C and which one's B. Alright, that's A. Let's see. Can't see what I'm doing, can you? C. So that one's B. And A is on the left side, so that means these need to swap. That should get me there. Wrong end. Come on, you bastard. One good thing is these wires are really tough. They're 18 gauge, so compared to the 22 gauge, they go in like no problem. This is really not correct protocol for a precision application, but that's not what this is. There's a rubber seal on the back with a small hole in it, so kind of like birthing a child. You gotta get these things in there. And the final step is snapping them into place. With this lip on the back, it's not easy to get leverage on there. There's like a big hole here that you have to get through in order to even push on them, and it's inside of a rubber seal, which you don't want to be sticking a screwdriver through. I'm gonna have to get out the third hand. You have to do that. You've been fed so many times. I might have to cheat a little bit with pin that hasn't been adulterated yet, so I don't want to go sticking a screwdriver into these pins because they are kind of somewhat precision. That's helping. They have to move forward just a very small amount and then snap into place. There we go. It's just that last little bit, getting them all the way in. And then we take this pin, put it back. I have another implement here to lock everything in place. But yeah, I think before I do that, I'm going to do a quick check of my pinnage. Make sure that's not jacked up. In which case, I regret putting that pin away. Because that's a helpful tool. Yeah, I want to test C. So C is ground. Like the most important one to get correct. Good. Now we want to mess with B. Does that match our documentation? Yes, it does. And then A. Got a beep. Continuity is good. Properly pinned. I can put this pin back in before I lose it. Actually have a proper place for these. These are all my Deutsch pins. That's a size 16. Apparently there's a size 16 that only works with 14 gauge wire, which I incorrectly ordered last time, and then you have these little bastards which go with the Deutsch DT micro connectors. So last thing to do to lock all these pins in place is just jam this in there in any orientation. Correct orientation. Yes. Here we go. One thing I did forget to do was I was going to put a label on here, which I now regret not doing, because I don't feel like depinning that, because that was a fucking hassle. But it's alright. Yeah, you gotta be careful. It actually melts the Flexopet a little bit sometimes. Be sensitive to that. That's where this little precision air blower helps. And then we got the big boy. Just trying to drag this boot up the connector a little bit. It's not easy because it's 6,000 degrees. The length is the same. I thought it looked like it was awfully long. I think that's close enough. If you care to see, I do have this. I mean, this is how it should look. And these guys sell all the boots to get that sweet, clean look. Not too far off, but these are specifically designed to go from large diameters to small diameters. If you're gonna be in the middle of everything, you might as well be entertaining. We bored? Good. Don't try to charm me. So this is the spicy wire, 120 volts, coursing through this bad Larry. Fortunately, it's not some shit that I hacked together. It's actually good quality stuff. It's not like imported, unknown materials. I know this works. Quit biting things. I managed to get the orientation pretty good. You don't have to do any weird twisting to get the wire to orient upwards. Good clean mate. And it's safe all the way to the heating element. God damn it, cat. You gotta stop eating things. You're running off with zip ties. Stop it. Pets, am I right? See if playing this music causes any issues. YouTube decides to mute me. So I was gonna wrap this thing in this red stuff as kind of like a safety reminder, but that would only mean something to me, so kind of decided against it. But I'll save this for another project where I really want something important to stand out from everything else. The safety factor here is there's only one plug of this type on the entire printer. There's no way you can plug this in wrong and blow something up. We have the bed thermistor, which I actually forgot to label. Kind of bums me out. But the important thing is they're together. Everything else is labeled, so good to go. Now it's time to start thinking about how to connect this to this. Excuse me for a moment. Okay. Do a quick documentation check here. This looks good end to end. There is one wire that is still yet to be made, and that's gonna go from the extruder up here down to here. So the cable that I need to copy is gonna be this, I think this long one. So I have to figure out which one of these is the longest and do the same thing. I don't know why I made the thermistor so much longer than the hot end though. That may have been an oops. Stop eating zip ties. Come on. Alright. Anyway. This is going to... oh shit. Running over leads from my multimeter, that's not great. Plus whatever the cat has done by chewing on them when I'm not looking. It's not playtime. Can't get any work done. It's like having an infant toddler running around. Infant would be a blessing. Infant would just sit there. So it makes my ears hurt. Well, I don't know. Which one does the audience want to see? I can make another cable like this, end to end, or start winging it and come up with some way to connect this thing to the 120 volts that's inside the power supply. Like, comment, and subscribe if you have a preference. In any case, now I need to think about this guy. Flush cut. Are you still out there? It's Ryan Pizza. Somebody's watching this madness. Alright, so these motor cables are 4-conductor cables. I'm just going to reef off 4 pieces of this length. have a sweet spool holder. That should be like printer project #1 when I get this thing back online. Which with any luck will be in the next couple days. This is 22 gauge wire. It's overkill. So I think the motor itself has like 24 gauge or maybe 26 gauge wires. So this is like more than enough current carrying capacity. And I've just started branching out into the 24 gauge wire. Because even these two with this ultra thin wall, I mean the wall thickness on this is like negligible. It's mostly the conductor inside is what gives it the girth. And when you bundle a bunch of them together, it still ends up being like a rather large, for instance that's still by my standards a fairly large cable, whereas the 24 gauge is even more slender, takes up less space. And then you have 26, and some guys are even getting down into the 30 gauge wire. 32. If you're good at strain relief, you can get some pretty small cable configurations that way. Your small diameter cable bundles. Plus it's cheaper. The smaller the wire, the cheaper it is usually. Oh good, my camera froze. I think I know what to do about that. This next step is kind of annoying. You have to take all the twist out of these wires, because they came off that little ass reel, which was wound pretty tight, and you can't twist these together as a twisted quad until you remove this springiness, or else it'll just become a rat's nest. So I can't even tell if they're the same length. I'm gonna assume they are. I'm gonna take a quick break. Be right back.
Father Ocean, hear my song. You're the wave I was made from. Take me back to where we once began. Ocean Father, I was wrong. Years I followed just the sun. Now I see your darkness holds the key. I close my eyes and I begin to see.